p? P is an irrational number, which means that it's a real number, and it can be expressed exactly as a common fraction. So the history of p is that it has been known for 4,000 years and it was discovered by the Babylonians. So p is a mathematical constant, the radius of the circle's circumference to its diameter, approximately equal to 3.14159. So what you have to do to get the p, the number p, you have a circle, and you have the diameter. So you have to divide the circumference of the circle by the diameter. So you have p is equal to circumference divided by the diameter. So it doesn't matter of the size of the diameter. If we divide the circumference by the diameter, it's always going to be p.
Okay, so there's two ways to use the p. One is the area and the other one is the perimeter. Well, first the area. The area is when you use p multiplied by the radius by the square. In this case, 2. So you multiply 3.40, that's the reduced weight, by 4, which gives you 12.56 meters. So the other way is perimeter. Perimeter is when you multiply p by the diameter. If your radius is 3, your diameter is going to be 6. So you have 3.40 multiplied by 6, which gives you 18.84 meters.
Okay, so the exponential function. The use of it is the exponential function is used to model a relationship in which a constant change in the independent variable gives the same proportional change. An example is when the percentage increases or decreases in the independent variable. You use it in physics, chemistry, engineering, mathematical biology, economics, and mathematics. I'm going to explain the exponential function. The exponential function is a shortcut for natural exponential, and it's represented as this. So the value is 2.718281. So we know the common function, and they work like this. You have a base that is a variable, and the power is a number. But in the case of the exponential, the base is a fixed number, and the power is a variable. So we have the positive x values, because we have an x right here, and the negative values. So we start to substitute the x to 0. So we have 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, 2 squared 2 equals 4, 2 to the power of 3 equals 8, 2 to the power of 4 equals values where we substitute as well. So we have 2 squared minus 2, which equals 0.25, 2 to the power of minus 1, which equals 0.5, 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, and 2 squared 2 equals 4. So the exponential starts very small, but they grow faster, and we know that as exponential growth. So I'm going to explain a little bit more the exponential growth. So it starts slow, but growing faster and faster. It can be double or triple. So that's how fast they grow. So, and the exponentials always have positive numbers as the base. We can see how the exponential grows really, really fast. So Leonard Müller introduced the letter E as a number in 1731. To know the exponential growth of something, and an example is the percentage.
The Gaussian ratio, known as phi. Okay, phi is a rational number that has no pattern, so it never ends. Okay, Fibonacci sequence and the Gaussian rate. Well, you here just see a 0, 1, 1, 2, on and on. But it has sequence. When you add 0 and 1, it gives you 1. When you add 1 and 2, it gives you 3. When you add 3 and 5, it gives you 8, and 8 and 5, it gives you 30. Okay. The curious thing on this is that when you divide it, it starts like 2 over 1, 2. But when you go on and on, it starts to be similar to the golden radius number, that is 1.618. So here it's very close, but it's a curious number because when you divide it by 1, like here you have 1 over 1.618, it will just give you the decimal, which is 618. So it is the only number that can do that. It's like no other number is gonna give you since when you have a line and you divide it and you have A and B. They together give you A plus B. So if you divide a plus b, it's equal to a plus b divided by a. So that will give you the phi, which is 1.618 equals